If you always wanted to observe your Ingress controller, then this episode is for you. We are going to study how to observe Nginx Ingress Controller utilizing logs. In this episode, we will see how to build a log stream pipeline exposing metrics. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of an existing series related to the Nginx Ingress Controller. And we'll see also it's almost related to logs. And we will try to answer to one single question: is the Nginx Ingress Controller observable? This episode will cover three solutions in three distinct parts. Part 1, as explained what is an Ingress Controller, and looked specifically at the Prometheus exporter's metrics. Part 2 has been focused on how to retrieve relevant KPI utilizing LogQL from Loki. Part 3, we will build a log stream pipeline exposing metrics from our Ingress controllers, and you will see that we will have the right dimensions, the one that we're looking for. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode, the part 3. We will start with an introduction, reminding the various LogQL that we have used on the part 2. Those LogQL will be very important because those will be used later on our tutorial. Then we'll present the various plugins of Fluentd that we will need to build our log stream pipeline. And last, we will jump into a tutorial. Introduction. In the previous episode, we were able to see that logs is clearly a data source that will provide more insights on our Ingress controllers. The advantage is that we can easily adjust the metrics by adding more metadata, more dimensions, the one that we're specifically looking at, to be able to split the requests coming in per ingress, per services, and way more. The advantage is that we can easily adjust the logging format produced by our Ingress controllers by adding extra metadata related to our context. For example, it will be meaningful to add the name of the ingress in our logs, the namespace where this ingress is being deployed, the target, the service that will basically respond to the ingress, and way more. In the case of the Nginx Ingress Controller, we can adjust the logging format by configuring the Nginx config file. In fact, in Kubernetes, it would be a config map. Nginx offers several variables exposing specific data. So here is the link to the Nginx documentation. Nginx offers several variables exposing specific data. So we have the variable byte sent to report the number of bytes sent by the client. Then we have another variable called request_time to report the request process time in seconds. The status, well, it's the HTTP status code. And then we have specific variables for Ingress controllers when you deploy it specifically in Kubernetes. You have the resource name, so that will be the name of your ingress, the resource type, in our case it will be ingress, resource namespace, the namespace where the ingress has been deployed, and last, the service. So by adding an extended logging format, we will expose the metadata required to observe properly our Ingress controller. In the previous episode, we have adjusted this logging format by adding this extra metadata. And with the new format of logs, we were able to utilize LogQL to parse the new metadata and utilize it to create metrics with the dimensions that will help us to split statistics based on the service, on the ingress name, and more. That is exactly the main objectives that we try to achieve through those episodes. LogQL is a really powerful metrics, but it requires to utilize Loki. So if you're not using Loki, our previous solution in our previous episode won't help you so much. So let's see how we could take advantage of the most popular log agent collector and forwarder of the market to have the similar metrics and be able to build dashboards. So today, I would like to utilize Fluentd, but you can also clearly achieve this with Fluentd as well. The plugins will be slightly different, but you will have the same type of feature. So first, before we jump into which plugins we want to utilize, let's have a look at the metrics that we were able to report on the previous episode. So in the previous episode, we built 3 LogQLs to extract 3 KPIs. So here's the first LogQL. This one is simply counting the number of log stream with a given filter. So we count by services, so we have the split by service, and we are making some filters to make sure to collect the right things. So at the end, the number of lines of log stream ingested means, in the context of Nginx, the number of HTTP requests. Then we did this LogQL, which is summing the number of bytes per ingress. Similar to the previous one, we applied several filters, so a couple of parser, but at the end we were mainly exposing the bytes. So that reports at the end the amount of bytes per ingress. And last, we did this LogQL that is utilizing quantile operator, so the percentile. So here, in this case, we applied the similar filters, but we exposed specifically the response time. So at the end, we were able to report the percentile 99 of the request time of our per ingress. And we can even go further by reporting metrics related to the status code. So if you want to report the status codes per ingress, we can also do that in a simple way. What are the various plugins required for our log stream pipeline? Like described on our dedicated episode on Fluentd, there are many plugins available to collect logs. It's going to be an input plugin. Then we have several types of plugins. We have the parse plugins to parse logs. We have filter plugin to filter the logs stream coming in Fluentd. And last, if you want to forward your logs to a storage, we will utilize an output plugin. In our case, we want to collect the logs produced by our Ingress controller. For that, we will utilize the input plugin tail that is made for reading logs from log files. And in fact, not all log files, we want to look at container logs files. So there are specific paths on our Kubernetes nodes that will basically help us to collect those logs. Because we were only interested to collect the logs produced by our Ingress controller, we can easily apply a filter specific to only limit the logs of our Ingress controller. And that we can use a regex character in the path of the log file. So here is an example. You can see that we have the path of any container's logs, but we are specifically trying to access the one that has Nginx in the log name. Then, once we have collected those log streams, we want to parse our log stream collected to extract available metadata. And Fluentd has several parser plugins, and we saw that on our dedicated plugins. We have the regex, the Apache, the Nginx, syslogs, CSV, and way more. In our case, because we're using Nginx, we will clearly take advantage of the Nginx parser plugin. It supports the default logging format of Nginx, and because we just customized the logging format, we would need to use an operator called expression to basically precise the structure of a log. So here is an example of the expression. It's basically combining regular expressions, and inside of the expression we can see that we are precising the keys that will store the data from our logs. So this will help us to extract the metadata and store it in your new log stream keys. Remember, we need the bytes percent, the request time, the status, the ingress name, the service, and that's why we need to parse to create those new keys. Because the objective is to expose metrics, we will probably need to precise the type of each of those keys, utilizing another operator called types. So types, you precise the key name and then the format, string, float, integer, and so on. So here is an example of the one that we will use. Once the metadata parsed and stored in the new log stream keys, we can either format our new log stream to send it to any observability backend, so Elasticsearch, Dynatrace, and many more. Or we can simply expose directly the metrics collected in a Prometheus format by using one of the plugins called Prometheus. The Prometheus plugin is not deployed by the default Fluentd agent, so you will need to install it on the top of your Fluentd deployment, or in the case of Kubernetes, which in our case, we will have to create a new container with the Prometheus plugin installed. So we'll have to create that image. So, by the way, here is the link to the official repository of the Prometheus plugins. There is plenty of documentation of examples. So what is the purpose of the Prometheus Fluentd plugin? In order to take advantage of the Prometheus plugin, we need obviously to precise to the Fluentd agents that we will expose Prometheus metrics. So we will use source to precise how to expose those Prometheus data. And there are several properties like bind. Basically, we will bind any IP address of the Fluentd agent, the port, which port will be exposing those metrics, and the metrics path. So here is an example of source settings for the Prometheus plugin. And by the way, if you want to apply TLS or SSL, there is also some TLS SSL properties. And if you want to apply that, I would recommend to look at the Prometheus plugins documentation. The Prometheus plugin has also another feature called the Prometheus_monitor capabilities. This one will automatically generate metrics related to our logstream pipeline. So Fluentd will produce and expose automatically metrics from our output. So they are various type of metrics depending on the type of plugin we use. So if using an output, then we will have Fluentd output status retry, so number of retry, the number of errors, the emit count, retry weight, the last retry time, the next retry time, and so on. The plugin expose automatically metrics related to our output and buffer plugins, so we saw that. If you want to report metrics related to data collected by tail plugin, you can also utilize another feature called Prometheus_tail_monitor. This plugin will report the file positioning, the current bytes which the plugin has read from the file, Fluentd tilefly inode, so the inode of the file. But all those plugins are relevant if you're interested to report observability metrics related to your log stream pipeline. In our case, we are looking to expose data from our log stream. For that, we will need to use the Prometheus plugin that could instrument metrics from our records. So here is an example. So you can see here we have a name for our metric, a type, we'll see that in a few seconds, the description, and which key we want to expose. The plugin describes the metric. So they have several properties in the metric. So you have a name, you have a type. So that's basically the Prometheus data type. So counter, gauge, histogram, and summary. The description and the key that will basically have the value, the metric that you are looking for. Then you can precise your labels. So the name of your label and the value of that. For example, here is an example here we have host, that will be the name of our label, and the variable host name will be one of the key from our logstream pipelines. You can also take advantage of a few variables that Fluentd naturally expose as well. The label object can be either positioned in the metric object or close to the Prometheus plugin. So out of the metric object, it will basically describe the common labels of all of your metrics that you're planning to expose. If the label is within the metric object, then we will precise the specific labels of that metric. So you can basically describe the common labels and then add extra metric labels in the metric object directly. In this tutorial, we will reuse most of the steps that we have covered in part 1 and part 2. So make sure to have a Kubernetes cluster, the Nginx Ingress Controller deployed, and also Prometheus deployed as well. In this tutorial, we will customize the logging format. In fact, it's already a step that we have covered in the part 2. Then we will create the Docker container having the Prometheus plugin installed. And then we will deploy Fluentd as a daemon set using our customized Docker image. And we will deploy our logstream pipeline with the config map. Once we have the metrics, we can then jump into Grafana to build a dashboard with those new fresh metrics. But remember, we will have to deploy a ServiceMonitor as well. Because Dynatrace is able to automatically scrap Prometheus data from any Prometheus exporter, we will expose those metrics in Dynatrace by simply adding Dynatrace annotations on the Fluentd daemon set. So once the data has been ingested by Dynatrace, we will also be able to create dashboards in Dynatrace. All right, so let's start.
Like every episode that we deliver in Is It Observable, there is always a GitHub repository related to this episode. Now we're looking at the series related to Nginx that we covered in 3 parts. So if we scroll down to the bottom, there is a new link to the tutorial related to our part 3 of this episode. In this episode, like discussed, we have several steps. So we already have deployed several stuff here. Like we saw on the part 2 or part 1, we deployed Nginx Ingress Controller with the help of Hemchart, and that has created as well a specific config map with a specific naming. So let's have a look at the config map in the default namespace. So here I have plenty of them, and the one we're looking at is the Nginx config file. So let's have this one. And as we see in this config map, we already had applied in the previous episode on the part 2 a specific logging format. And you can see that I won't modify it, but this is the logging format utilizing Nginx variables that will provide extra metadata. So the remote address we have, it's the IP address, the time, the request. Request, in fact, is a combination of methods, path, and user agent, and so on. The status code, we have it, and we have added a request time, of course. And then information related to the upstream address, the response times, the proxy host. Very interesting information. because it will be basically the endpoint where the user is connecting to, and the status, and then we're looking at the resource name. So the name of our ingress, resource type will be, of course, the ingress. So nothing special for us. Resource namespace obviously is where the ingress is being deployed. So here in our example, in the part 2, we have deployed 2 distinct ingress, one for the hipster shop and one for the Grafana. So both are accessible through the ingress and are going through our Nginx Ingress Controller. So at the end, we're supposed to have it be able to split by the namespace related to Grafana, which is the default one, and the namespace for our online boutique, the hipster shop, which is hipster shop. And last, we have the service. So service is which service is addressing the traffic. So in our case, in our example, we have, of course, the Grafana service, and on one hand, and the other hand, we'll have the front-end services of the hipster shop. We will have to build a Docker image. But before we jump to building the image, at the end of this tutorial, we will require to have Dynatrace. So for those who doesn't have Dynatrace, it's not a big deal. For those who doesn't have Dynatrace, it's not a big deal. You can start a trial. So if you go to dynatrace.com, there is a trial button here. So you can put your email address and everything, and you will receive later on all the details to connect to your dedicated tenant. And you will be able to deliver the last steps of these tutorials, where we will try to connect our pipeline, logstream pipeline that we've built with your Dynatrace tenant. So that's the first thing. All right, now, as you remember, we are going to use in this pipeline various plugins. So we want, of course, the Dynatrace Fluentd plugin to allow us to ingest metrics in Dynatrace. That will be one of the last steps of the tutorial. And we want the Fluentd Prometheus plugin. So this one is not installed by default, which means we would have to create a specific Fluentd image with all the plugins that will be required for this tutorial. So in this GitHub repo, I have listed the plugins that we need to install. And by the way, I already have built my own Docker container, which is available on Docker Hub, by the way, so you can take advantage of this. But let me show you the Docker file that I'm using for this image. So I'm using one of the latest version of today of the daemon set, Fluentd Kubernetes daemon set, and I'm adding I want the forward plugin because in our case we don't use forward, but it's still useful to get the forward plugin as well. Then I deploy, so I go through the standard image built by the community, and then I add the various plugins installed to install. So a Dynatrace. I want to utilize the Kubernetes metadata filter, which is to add extra tags and metadata related to Kubernetes. We need to change the records to have multi-lines. We want to, and then last, we want the Prometheus. So if you want to build your own container and make it available on a local Docker registry, feel free to do so. It's the command to build a container is here, nothing complex, and you will be able to have advantage of this. But keep in mind that I already have built my own Fluentd image on my own Docker Hub account, so you can have access to it directly by following the various steps. Because we're going to use Dynatrace, there are a few things we need to do within Dynatrace. So first, we need to generate what we call a pass token, and we need also an API token. So those are the two things that will be required. In this pass token, or in this API token, we need some couple of rights to be able to ingest metrics, because we're going to ingest metrics and we are going to ingest also logs. And I also add in the screenshots the open telemetry traces. It's not mandatory in our example, but feel free to add it as well. So let me show you in Dynatrace where you can do that. So you will have to go to the access token here on the bottom of the main menu, and then you can generate new tokens. And in these tokens, there are a few templates. So if you want to use the pass token, use the template for pass token, give it a name and the expiration date if you want, and then that will be fine. In the case of the other token, so you can say, for example, test, and then we will have no templates, and then you will have to look search for metrics, for example. So here, ingest metrics, this is what we want to do. Then we want to have logs. So we want to ingest logs, and then we said traces. Here, ingest OpenTerm traces. So you just have to search for different aspects. And then once you have done it, you can basically say generate token. Once you have generated token, make sure to copy the value that will be displayed after the creation of the token, because it won't be displayed twice. So make sure to copy this to be able to take advantage of that for the next step of the tutorials. And you will see we will need those tokens later on the steps, because once we go further, we will basically create all the secrets that will allow it to deploy a service account, and we will deploy what we called an active gate. An active gate is a component that will allow us to be a sort of a bridge between your Kubernetes cluster and Dynatrace. And so if you want to securely communicate logs and things between Dynatrace and your cluster, you can go through an active gate. It's not required, but here it makes your life easier. And especially we will see we want to ingest Prometheus metrics. So we will take advantage of that feature through the active gate. The other thing that is important related to your Dynatrace tenant, you can see I need the environment URL, I need the environment ID. So the pass token, I showed you how to do that. API token as well. Cluster ID, you will see it's going to do through this command. So it's already described. But I'm more interested to show you how to collect the environment URL and the environment ID. So if you look at my Dynatrace tenant, which is here, I have here in the top the link of my environment. And in this link here, so if you just focus on the main URL, so here it's a dev tenant, it's not a production tenant, but you will probably have an URL with a live.dynatrace.com. But you will always have those few numbers, or the first piece here in the URL is basically the environment ID. So you need to have that environment ID noted down somewhere. You will have it later on. And then, because we're going to interact with the API later on, we need to have the full, what we call environment URL. So don't get the HTTPS, just focus on the host. So in my case, it's the environmentid.dev.dynatracelabs.com. In your case, it will be environmentid.live.dynatrace.com. All right, so I'll let you run this command to get your cluster ID. I have also generated my tokens. So make sure to do that. Make sure to export all your variables. I will do it on my own, so I don't want to avoid showing you any sensitive data. And let's first of all apply the service accounts, because we are going to run Fluentd in our cluster. We will need to obviously have a service account. So let me show what type of rights we need. Let me show you service account, which is here, because we are going to collect logs with the Fluentd and to send it over to Dynatrace. In fact, so it's going to be a similar service account. And we need basically to have access to nodes, to pods, to namespaces, to a lot of things. And in the cluster, because at the end, Fluentd will be deployed as a daemon sets on all the nodes. So it means it's not on a specific namespace, but to the cluster itself. All right, so now that you know which type of rights that will be applied, let me apply this. All right, so here, so in the repo, if you go to the Fluentd folders, which is here, there is the service account, the service account. And this service account, technically what it does at the beginning, it also creates a namespace Dynatrace. So just apply it, called kubectl. That will create our namespace, the service account, and the various cluster rows. So that is done. Then, like I said, let me apply the various commands. All right, so that is done. Now let me just create the first secret, taking this command, or we can basically copy paste both commands indirectly and apply them. So now that we have this, we need to modify few of those configuration files. So why? Let me show you briefly those files one by one. In each of those files, especially the ActiveGate, Fluentd and ActiveGate, there are a few references on how to connect to Dynatrace, especially to get the image of the container. So that's why you need to replace this one. So this variable doesn't exist. Similar to the Fluentd manifest, there are also a few reference to the cluster ID, the environment, and so on. So that's why we need to go through those manifest files to update and refer to our various stuff. So I would recommend to go through this one, so you can see that we are currently at the Fluentd folder. If you want to make it work, make sure you go at the root folder of the tutorial, and you can basically copy paste those things here. Let me grab those and do it. Now we have sort of configured everything. Now we can deploy our ActiveGate and the Fluentd, the manifest. And then I will walk through the pipeline itself, what it does, and the various things, the aspects that that. So let me apply this. And so we have the ActiveGates created, and the second one, we have our Fluentd also created. Wonderful. Now that we have this, we have to also do something else. We have to connect our ActiveGate to our Dynatrace tenant. So that will be required. In Dynatrace, you want to connect this ActiveGate to the cluster. You can do it through API calls, but for the sake of this exercise, you can do it through the UI. So make sure to get the API server URL, so by applying this command. And the second one will be the beer token for the API server. So now I got the information, so let's go back to Dynatrace. So here I have Dynatrace, and I want to connect a new Kubernetes ActiveGate. So here I already done it, and in fact I have let's go to the settings of this one. So I can re-enable it. The URL is the same. The only thing that has been changed, because I have removed everything, is the beer token. So let me grab my token, so I will be able to connect to it. Then we will leave it to default. We don't want to require a valid certificate. We don't check SSL. We don't want to check the host name. And make sure to monitor the workload, to monitor the annotated Prometheus exporters, because we're going to take advantage of this one, and also get the events. So let's save this one. So let's test the connection first. Okay, successful connected. So I can say save changes. And now if I go back to Kubernetes, you can see that we have everything that has been is coming in Dynatrace. So this step is done. So this is very important because it will allow you to connect the ActiveGate that we've just deployed in our cluster with your Dynatrace tenant. So now that we have all the, I would say, most of the technical component deployed, let's have a look on the pipeline. The first step we need to do on the pipeline is obviously we want to read logs from our Nginx container. So for this, we're going to use tail. Tail is basically the plugin that reads the files. We mentioned that on the various episodes. And here I'm not interested to get all the logs of all the containers. Doesn't make sense. That's why I'm putting here a filter to say I just want to collect logs from containers having Nginx in the name. Then I tag my log with Nginx, because I will see later on in the pipeline, I would need to basically filter only the logs that comes from that source. Once it's there, I use the parser Nginx, and like discussed, because we have adjusted the format of our logging from our config map, we need to rebuild the expression. So here I'm building an expression, and this is basically precising to Fluentd the key name and how to extract it. So here the regular expression related to the key name. So this has been done. So you have, it describes the entire log format that we have applied today on Nginx. And then I use types to match those names. So here you can see that we have IP here, and IP is a string. Then we have time local, which is here, which is a string as well. So then you go through all those details. Then I mentioned that time format is the one that is here. And this is basically this piece here in this pipeline will allow us to collect the logs from our source, which is Nginx. Next, we want to make this pipeline, logstream pipeline, exposing metrics. So I need to define my Prometheus exporter. So here I'm defining a source, Prometheus. So it's the type Prometheus. I'm binding any IP address on the Fluentd containers, and I'm exposing the exporters on the port 9914, and the path for metrics will be, for Prometheus, will be /metrics, the standard one in general for Prometheus. Once we have done this, and we have the various keys that we have extracted from the logs, we need to go through building and various metrics that we want to expose. So, like explained, here I'm filtering only the logs that has the tag Nginx. So that was matching with the source that the logs coming from the Nginx container. I'm defining some labels, and you can see that I'm doing, say, I want to have a label called method, and here this means it's a key from the log stream, and because we have already extracted it from through the expression, we have this key called methods that has been defined, so I can mention it then as a label. So methods will be methods, variable, request will be the key called request, status will be status. So basically here what is going to do, I will have one label, one dimension per request. So then we can make some calculations, we can be very creative on what we can do that. Then I'm adding as well what we call ingress namespace. So the namespace where the ingress has been deployed. Remember, we had one in the default namespace and one in the HipsterShop namespace. Then we have the target service, so the front end or the Grafana services, and the resource name. So the resource name is the name of the ingress that is serving that traffic. So that will be all the common labels like we mentioned. If you put labels out of the metric plugin, it will be the common labels for all your metrics. And then here you can see I'm defining 1, 2, 3, and 4 metrics. So 1 metrics for called response times, where it's going to be type gauge at the description, and then I'm pushing in the gauge the value of the variable response times. So here it's I don't have to refer to dollar in response times. I can refer to exactly the key name that we have. I do the same for the byte send, and then I want to have a metric that will be a counter, basically that counts the number of log streams in Nginx, and the log streams is basically a request. So that will allow me to count the hit per seconds, the number of requests per seconds that we have in Nginx. Last is the status. So we mentioned that we may want to also report some statistics around status with the various dimensions, so splits by different stuff. So that's why I'm pushing also the status. So we will have 400, 200, 304, whatever. So we can imagine any graphs with that statistics. So that's basically the pipeline itself that we have applied just now. So if we want to, you can, of course, to debug, what I would recommend is I've already added in this current manifest of pipeline, is to have a match the output plugin std_out. Why? Because I want to check the structure of the log stream. Here in this case, I've already worked on, so it works pretty well. But especially if you use expression, it could make sense to test, to make sure that what you have extracted, those keys that has been extracted will be visible in your log stream. So it makes sense to print it out in the std_out to make sure that everything is, all the values that you're extracting is properly formatted. I'm gonna do so the Fluentd has been deployed in the namespace Dynatrace, and we can see that we have our 3 Fluentd pods running, one per node. All right, as you can see here, we have a lot of logs coming in, and this is basically how it's been extracted. So as you can see, we have this JSON content with the various keys that has been extracted: the log time, the log type, the IP, the methods, the requests, and so on and so forth. So it means that all the extraction that comes from this pipeline is working perfectly. And as a consequence, it means that I may have some Prometheus metrics that has been exposed by this Fluentd container. So if you want to get those metrics and build a Grafana dashboard for that, we would need to deploy what we called a ServiceMonitor in Prometheus. Because we deployed the Prometheus operator on the previous episodes, the Prometheus operator comes with a couple of CRDs, and the ServiceMonitor is the way of connecting, of precising to Prometheus server to say, hey, there is a new exporter, please grab it. So first to do that, the ServiceMonitor needs to connect to a service. And so let's create a service. So here I have one service, which is here, which connects with a label selector, the Fluentd pipeline, which is only selecting the Fluentd containers. And then to scrub the Prometheus metrics, we can add the Prometheus annotations. As you can see, also I've added the Dynatrace annotation as well, because when I will apply that Dynatrace, because there is an active gate, will also scrap automatically those metrics from that is being exposed on the Prometheus format. Once we have the service running, then the only thing we need to do is to deploy the ServiceMonitor. So ServiceMonitor will basically match with the service that we have just created. The good news is that we have this file already created in our repository. In the Prometheus folder, which is here, you have the ServiceMonitor Fluentd. And that is exactly what we're looking for. So the only thing we have to do, if we go back to our terminal, and that's it. So now we have those metrics created, which means that we can, in few seconds, with let's generate some few metrics here and there. So, because every time we do a click, there's a request, and the request generates a log. So now that we have deployed our ServiceMonitor, we have metrics coming in Prometheus, and we can utilize them in Grafana. All right, so let's start with, so this is our existing dashboard that we've built on over the last few episodes. So I removed Loki, so that's why we don't have the Loki charts anymore. So we can see that the amount of bytes per service, the number of requests per service, per ingress, and the P99. So we can somehow build a similar metrics. Without Loki, without LoQL. First of all, we have 3 distinct metrics that has been built. So let me show you briefly. So we have it here. So we have the ingress byte percent, the ingress response times, and the ingress request. We also have the status. So we'll start with the ingress response time, all right? And then we will move on to the other. So let's start with, I want to have, we can have the P99 if we want, but let's start with something concrete, and we're going to do the average. So let's do the average, and we want the, so first, we have several dimensions, so we will do a split. we want the average ingress response time. So let's start with simply with this query, nothing specific. So now we have the value, interesting, and this metric has several dimensions or labels that we saw. So we have, let's say we can see that the service that is addressing this ingress is called target service. So this is how we named it in our Fluentd pipeline. So if I do the same query, all right, so now I can see that I have two values of Prometheus, perfect, front end, so it's the shop. And then I have values. Values is probably the health metrics that are going through the ingress. Probably don't want to have that plotted. It doesn't make sense for us. So I may probably do a filter here on the label selector. So I will take the target service like this, and I don't want to be equal, but I doesn't want to be different from empty. So it doesn't means that there are no services. And now we can see that now we have the average response times in seconds of the two ingress. So this is what we will want. So this put it average, and I can apply that. So now we have a new dashboard that will present this. Next, what we can do is we also, of course, I can adjust the design of the dashboard, but we're not here to design the actual visualizations, but more the data that comes in the graph. Now, let's focus on the, we have two things. So we have the bytes per second. And now I can see the bytes exchange. So here I have just two apps, but this graph could be even more powerful if we were having several services going through this ingress. That will have lots of relevant information for us. So now that we have the byte and the response time, the last we need the requests per second. And the request per second, as remember, we're just counting the number of lines through a counter. So because it's a counter, we may need to go through rate, because rate, as you remember on the PromQL tutorial, it's for counters. To do that, let's start with the rate. It's simple. So ingress request, so without any filtering. And I want to have the rate per second for the last 10 seconds. So that will be my timing. Let's plot this one. And now that means that we are summing per target services. So we have the incoming traffic per second. So that's typically what I wanted to show you with Grafana. So let's save this dashboard. Here it is. Because we also add the annotations in Dynatrace, it means that those metrics is also coming in Dynatrace. So let's jump into Dynatrace and let's see these metrics. So I'm gonna look at it, and the metrics in Dynatrace, once they are ingested through Prometheus, you can first see them in metrics, obviously. And then we have the explore data, where we can, similar to what we did in Grafana, we can build queries to add them in dashboard. So let's have a look first of this ingress. Let's first for ingress. Oh, here it is. So now we can see that we have our 3, 1, 2, 3, 4 metrics. So which means if I utilize those, I can then go to the metric explorer. So let's say I wanted to look at the response times. Let's go to the export data. We'll do the same thing. So ingress. I should have ingress underscore. What was the name? So ingress underscore response times. This one. And then let's say I want the P9. All right. And let's query that. Now we have this. And now we have dimensions. And remember, what we want, we could split it by our target service, which is here. Then we can make some split from the similar to what we did in Grafana. So the metrics is in Dynatrace, so then you can do whatever you want. You can create queries, you can create pie charts. You can be very creative, by the way, on how you want to do things. All right, so that's the first piece of our tutorial. The next section is we want to update our Fluentd pipeline to also ingest the logs data that we had produced through Ingress. For this, I have already prepared the config map for Dynatrace. And the major difference that we'll have here is we also going through the metrics, same thing, because we still want to produce those metrics. At the end, what we're going to do is going to provide a filter. And it's not a filter, it's a record transformer. We want to create a new field called content. And then content will have a couple of information, the method, the request, status, the service, the bytesend, a few information. So then I will be able to store it as a log stream in Dynatrace. Then, because we want to index the log stream to specific entities in Dynatrace, I need to push the node ID, UID of the Kubernetes node where this is running. The data is coming from the cluster. I want to also add the namespace, the service, and because we have those records already extracted previously from our log stream, it's very simple because I can basically match the resource namespace to Kubernetes namespace, the service to the Kubernetes service name, and so on and so forth. And last, the only thing that I need at the end to be able to push that information to Dynatrace is to utilize the output plugin Dynatrace, where you need obviously to precise the ActiveGate URL and the API token, so then you will be able to ingest. So let me apply this change in our config map. Keep in mind that this file, we also need to update it with the set command. So we already did it on the previous step. All right, the config map has been applied. One thing which is really important is we have, they are currently running and they are using still the previous configuration of our config map. So if you want to force Kubernetes to restart new fresh containers, Fluentd container pods with this new config map, the new updated config map, we need to delete the pods. And because we want to ingest logs, we can check the log viewer here. And here that shows you all the logs that comes in this particular Dynatrace tenant. And now we have logs that are related to our cluster. And in fact, if I see the structure, I know the structure, you can see that we have get product 200 front end. That seems pretty much related to the traffic that we had. And if I expand, I'm pretty sure that this is one of the log lines. Hipster shop, online boutique. We have a couple of upstream status, all the links that we have extracted. So this is exactly the information that we have. So with that we have produced through the log. So I can also filter. So I say I want to look at the cluster. Is it observable? Here it is. So now we're only looking at our logs. So we have applied 3 filter logs and hipster shop. I didn't specifically filtered, and then you can see that we have this. So then if I want, so I can create a metric. Let's do this. So we give a name to this one, and then we have this, you can add dimensions as well. So the measure occurs of a log group or attribute value. So then I can select. So now I can look also the response times. So I can say log Nginx dot response times. So now I got a metric as well. And now what is important is to add the relevant dimensions. it's saved.
That's it for today's episode, the part 3 of the Nginx Ingress Controller. And that's the end of our series related to the Nginx Ingress Controller. Today, we have provided a solution for anyone who's using Fluentd or probably Fluentd to basically expose the metrics from our ingress with the right dimensions. So then we can create any type of dashboards and understanding where we have problems. So if you enjoyed today's content, don't forget to like and subscribe to the channel because we are going to produce more episodes in the next coming weeks. Thank you for watching. See you soon for another episode. Bye.